Vibe programming represents a shift from writing syntax to describing intent. Traditionally, developers managed structural details such as braces, types, imports, and memory. With modern AI systems, the bottleneck has moved. Developers describe what they want, and the AI generates the code. This changes the role of programming languages. They must now be easy not only for humans to write, but also for AI systems to generate correctly and consistently. Sheerpower fits this model well. Its small grammar, consistent patterns, and deterministic behavior make it a strong target language for AI-assisted development. Programming is shifting from writing syntax to describing intent. Instead of manually implementing every detail, developers describe what they want the system to do, and AI generates the implementation. This changes the role of programming languages. Languages must now be easy not only for humans to read and write, but also for AI systems to generate correctly and consistently. Sheerpower fits this shift especially well. Its small grammar, consistent patterns, and deterministic behavior make generated programs easier to produce, easier to verify, and easier to maintain. In this tutorial, we'll explore why Sheerpower works so well with AI-assisted development. First, its small and consistent syntax helps AI systems generate correct code more reliably. Second, Sheerpower reads like structured English, making it easier for prompts to translate directly into working programs. Third, features like views and clusters make data processing both simple and fast. And finally, Sheerpower's runtime removes several common bug classes, making generated programs safer and easier to verify. AI-generated programs often fail for simple reasons, not because the algorithm is wrong, but because the syntax is complex. Large language grammars create many opportunities for mistakes, missing braces, mismatched types, indentation errors, and excessive boilerplate. Sheerpower avoids these issues by keeping the language small and consistent. It uses only a few core types and uniform statement patterns. This greatly reduces syntax pitfalls, making both human-written and AI-generated code easier to produce and verify. Sheerpower keeps the type system simple and predictable. There are no pointers, no manual memory management, and no garbage collector tuning. Instead, the language focuses on three core types: string, real, and Boolean. Visual suffixes make variable intent immediately clear, $signs for strings and question marks for booleans. This simplicity helps both humans and AI systems infer types easily, reducing type-related errors in generated code. A powerful aspect of Sheerpower is its consistent statement patterns. Once a developer learns the structure of one operation, the same pattern applies throughout the language. For example, cluster processing and database queries both use the same declarative structure: include, sort, and for each. This consistency reduces cognitive load and makes programs easier to read. For AI systems, fewer syntactic variations mean more accurate and reliable code generation. Sheerpower reads like structured English, which makes prompts map naturally to code. A data task prompt often translates directly into program structure. Define the data, load the file, filter the rows, sort the results, and iterate through them. Because the code closely mirrors the original intent, AI-generated programs are easier to produce and easier for humans to review. This example defines a cluster that represents city data. Clusters act like structured records, grouping related fields together. The collect block processes the cluster declaratively. The include statement filters cities with populations over 10 million, and the sort statement orders the results alphabetically. This pattern resembles database query logic, but it operates directly on cluster data structures, making the code both expressive and easy for AI systems to generate. AI-generated programs often work correctly but perform poorly. This usually happens when parsing code repeatedly scans text or copies strings into new buffers. Sheerpower avoids this with its view system, which allows programs to reference portions of a string without copying the data. Combined with cluster workflows, this enables high-throughput data processing with very little memory overhead and no manual optimization. This statement demonstrates view-based parsing in Sheerpower. Instead of copying each line from the log file, the program creates a view into the original data buffer. The piece operation selects the next segment using the separator, allowing the program to process the file line by line. Because no new strings are created, memory allocations are minimized and performance remains high. For AI-generated code, this means efficient parsing can be produced without requiring the model to understand complex low-level optimizations. Sheerpower includes a built-in ARS database system that uses a declarative query style. Instead of constructing SQL strings, queries follow the same pattern used for cluster processing: extract, include, sort, and for each. This eliminates several common problems. There is no string concatenation to build SQL commands, which reduces injection-style risks. Most importantly, the intent of the query is visible directly in the structure of the code, making it easier for both humans and AI systems to understand. Another advantage of Sheerpower is that many common programming mistakes are eliminated by default. For example, real values use exact decimal arithmetic, which avoids the floating point rounding problems common in many languages. The runtime also manages resources automatically, preventing memory leaks and simplifying program structure. As a result, both human-written and AI-generated programs are safer and more predictable. Vibe programming often starts as experimentation. A developer generates a small prototype to explore an idea or test a workflow. In many environments, that prototype must later be rewritten to become a production system. Sheerpower avoids this step. Programs written for experimentation can grow directly into production applications. Fast execution, simple deployment, and built-in web capabilities allow the transition from prototype to production to happen smoothly. Large Sheerpower applications often organize code using %include files, which divide programs into smaller modules. While this improves maintainability, it can make analysis more difficult when the logic is spread across many files. For AI analysis or documentation, it is often helpful to view the program as a single expanded source file. Sheerpower provides tools that merge include files into one complete listing, allowing both humans and AI systems to see the entire program structure in one place. In the era of AI-assisted development, programming languages are no longer used only by humans. They are also targets for code generation systems. Languages with small grammars, consistent patterns, and deterministic behavior provide a simpler and more reliable foundation for building software. Sheerpower was designed with these principles long before AI coding became common. As a result, it aligns naturally with the goals of Vibe programming, making programs easier to generate, verify, and maintain as they grow.